Good morning, GLA middle schoolers. It is Mr. Manta here. We got another lesson coming at you for science today. Today's date should be Thursday, May 7th of 2020, and we are moving along with our chemistry unit. We're getting into some pretty advanced stuff in chemistry today, which is making me really excited. Because chemistry is the kind of thing that the more you understand, the more interesting it gets. Early on, we were just talking about matter and properties, which is necessary, but now we can get into the more complex stuff. Yesterday, we had our lesson doing those experiments with baking soda and vinegar, and today we get to start talking about what is an atom, this very important concept, this fundamental building block of matter. But before we get to it, we're going to start out, as always, with our do now. You should have your notebooks out and a pencil in hand. Pause the video and answer these 5 questions for your do now. Alright, I'm assuming you've now got your answers written down in your notebook because we are going to go through them together. Number 1, in a chemical reaction, you start out with your reactants and end up with your products. That is what a chemical change does. It turns reactants into products. Number 2, true or false, the law of conservation of mass is true for physical changes and chemical changes. That is true. Yesterday we proved that it is true by doing that experiment with baking soda and vinegar where I had the glove up on top of the water bottle and the whole thing weighed 98 grams before and after the chemical reaction. So it's true for physical and chemical changes. Number 3, the most important thing about a chemical change is that a new substance is made. That's what makes them different from physical changes. Number 4, what were the reactants in yesterday's experiment? Well, the reactants are the things that you start out with, that you combine to see what happens, and ours were baking soda and vinegar. And number 5, all matter is really made up of tiny particles too small for us to see. I know we've said that like 10 times by now, but it's important to start out today's lesson with because we're about to get a little bit more advanced than this idea of quote-unquote particles. Now, before we jump to new material for today, I do have to shout out a couple of my students, both in Purdue. I have Ali up here and JL right here, because they were the 2 students who not only did the baking soda and vinegar experiment themselves, but sent me some awesome videos of it. I heard a couple other students also apparently did it, but I didn't get videos from them, so I can't show you guys. But I do really quickly want to play this video that JL sent me with her and her mom doing the experiment, and then I'll play Ali's right after. I can see here JL was very thorough about following all the instructions, doing it just like I did it, but she used a cup instead. And her and her mom poured the baking soda from the thumb of the glove into the cup, and let's see what happens. Da-da-da-da. And would you look at that?
Hi, Mr. Manta.
I gotta say, JL, you're kind of making me look bad, because that one looks even better than mine. That looks very clean, it was well put together. That is a waving glove if I ever saw one. The gas being made from the carbon dioxide from the baking soda and vinegar are filling up that glove, so it is waving on back to us. Now, Ali's was also very entertaining, maybe not as well controlled as JL's, but I'm really enjoying it. Check it out.
Hello, Mr. Manta. Here we have baking soda, here we have vinegar. So, today I'll be doing this, because my mom and dad taught me how to do this, and my assistant Ryan here. Ready? Now.
Oh man, that's a lot. Oh!
You gotta hold it tight.
Good call, Dad. You gotta hold it tight.
It's squirmy, yeah. You're supposed to hold the top. Oh, that's awesome.
Man, y'all made a mess.
That's
More.
enough. It's cold. That's enough.
Da-da-da-da.
Y'all know it's called a chemical reaction. Do you like that?
Man, I don't...
Good stuff, y'all. You guys made a mess. You filled it up so it filled over the water bottle. That's what happens when you add a lot of baking soda and vinegar, I guess. I appreciate that from both of y'all. You'll be getting some scholar dollars for it, and you won major points with Mr. Manta. If we do have, hopefully we'll continue to have some other experiments going forward. If you did that one yesterday and you want to send me a video still, please do. If not, keep an eye out for more experiments moving forward. Now, on to today. Today's mission is going to be what this guy is saying right here. We are stepping our game up today. We are taking things from like a 4th grade level up to a proper middle school level understanding of chemistry and particles and matter, because so far in chemistry we've been using this term particles a whole lot. We've said all matter is really made up of these tiny particles. And that's true, but it's a little too simple for us moving forward. I want us to be even a little bit more clear and more scientific and when explaining what it is that we mean when we say that matter is made up of particles. So from here on out, we are actually not going to be using that word particles anymore. Instead, we're going to be using two different words to be specific about what kinds of particles we are talking about that matter is made up. Because really, matter is made up of two things: atoms and molecules. Atoms and molecules. I haven't introduced these two words yet because I wanted us to get kind of the basic ideas of chemistry down first. But now we're going to start thinking about atoms and molecules instead of just particles. Particles was a generic term that means both atoms or molecules. But now I need to be more specific with these words. Today we want to put on our big boy pants and start talking about what is a molecule and an atom, these kind of technical terms, but I think you guys can handle it. So today's big questions are simply, what's an atom and what's a molecule? To start us off, we are going, as always, to Crash Course. Listen up carefully. I'm going to skip through part of the Crash Course video today, but that's not as relevant to what we want to talk about, but we'll hear from most of it, so listen up carefully.
Have you ever thought about all the different kinds of groups you're a part of? If you consider it for a minute, you'll find that there are probably a lot of them, and some of them are more alike than others. Like, there's the friends you hang out with, and your family, your hockey team, your Crash Course fan club, and that's just for starters. And even though these groups are totally different, in each of them there's something that all of its members have in common. Like, your family may be from the same town, and your friends may all be into Avengers movies. A couple of episodes back, we learned that all objects, that is, all things made of matter, have properties, qualities that make them different from one another. Like, the metal water bottle we had in our lunch bag was a good conductor of heat, and the fruit strip was more malleable than the potato chip. Just like groups of people have major things in common, so do different materials. Instead of a love of superheroes, though, the things that these groups have in common are properties. So, how does that work? How can we group materials by their properties? You already know that everything is made of matter. Some of the particles that make
Alright, listen carefully. Some of the particles that make up matter
are called molecules, and the particles that make up molecules are called atoms. Now, molecules and atoms are the smallest units of a substance. A substance is just matter that's all made of one kind of atom or molecule. And since it's all made of the same stuff, it all has the same properties. Take water. Whether you have one drop of pure water or a swimming pool full of pure water, the water is made of the same molecules, and so it has the same properties. So water in the droplet and in the pool would have the same freezing point, reflectivity, and so on. But wait, there's more. If we look really closely at a water molecule, we'll see that it's made of two other substances. And if we had the right equipment, we could break the water molecule down into smaller parts. The atoms of those two substances, hydrogen and oxygen. These substances can't be broken down into any other substance, so we call them elements. Elements are the very most basic kind of substances, and they each have specific properties. So that, basically, is what stuff is made of. Now,
Alright, I'm going to skip ahead to the conclusion because I want to focus on the stuff about molecules and atoms specifically. She spends some time talking about different ways that we can group objects by their properties, and that's cool, but I don't want us to get too distracted today.
So, a substance is matter that is made of one kind of atom or molecule. Substances have specific properties, like reflectivity and magnetism. And once a substance can't be broken down into any other substance, it's called an element. And elements have properties too. We were able to group objects made of different materials into groups based on things that they have in common. Specifically, properties like transparency and reflectivity. And we noticed that there are objects that have similar properties that have other things in common too. Like the objects that were attracted to the magnet were made of metal. So, objects that have properties in common seem to frequently be made of similar substances. And speaking of groups that have things in common, I'm due to meet my peeps for a comic book movie marathon.
Alright, I hope you all have been enjoying some comic book movies lately. I certainly have as well. I want to follow up on what we just learned, though. I want to make it clear what it is that we're talking about with atoms and molecules. So here's our recap from the Crash Course video. I'm going to quote directly from the exact words that Sabrina just said for our key points today. So if you want something to write down in your notebook, these would be good parts. First of all, she talked about matter, molecules, and atoms. Specifically, she said some of the particles that make up matter are called molecules, and the particles that make up molecules are called atoms. So that's our first idea, is that when we're getting more specific about these particles, really what we're talking about are molecules. And then molecules themselves are made up of atoms. So you have matter, which are big objects that we can see with our eyes, molecules that are way too small to see with our eyes, and then atoms that are even smaller, and that's what makes up molecules. The second point that she made was trying to explain what atoms really are. She said, if we look really closely at a water molecule, we'll see that it's made of two other substances. We could break the water molecule down into those smaller parts, the atoms of those two substances. The point is that water molecules, even though that's the smallest possible amount of water that you could have, even a water molecule could be broken down into smaller atoms. Water molecules you often see in chemistry because they're a good, just simple example of what a molecule looks like, and they have, we'll see it in just a second, but these are all little diagrams of water molecules floating around her. In reality, they're of course much smaller than that. So just to be really clear, what is a molecule exactly? This is the definition that I like. Molecules are the particles that make up most of the substances around us. They themselves are made up of atoms. So in this diagram, we're seeing, it looks like we're looking at some kind of ocean wave or something, and it's made up of water, and of course it's showing for us all the little water molecules, these tiny little small particles of water. But then if that's a molecule, what's an atom? This diagram makes it really clear. So over here you have a water molecule, and that's the smallest bit of water that you could possibly have. But you can even see when you look at the water molecule, it looks like it's made of this big red ball and these two little gray ones, right? So the big red one is supposed to be representing an oxygen atom, and the two gray ones are representing hydrogen atoms. And a water molecule is made of one oxygen atom and two hydrogen atoms all put together to form a molecule. Specifically, atoms are the basic building blocks that make up matter. They're the smallest possible objects we could talk about that have properties. Different types of atoms, she also mentioned this in the video, are called elements. Elements, that's a very key vocabulary word that we're going to keep on hearing moving forward that you are responsible for knowing. It's a different types of elements, or different types of atoms. So oxygen is an element and hydrogen is an element. And molecules are made of atoms bonded together. Like this water molecule right here is an oxygen atom bonded with two hydrogen atoms to make a molecule. Now, some molecules that we'll see in science and in the world are very simple. Water is a good example of it. You might have heard before that people can sometimes call water H2O. Well, that's because that's what a molecule of water actually looks like. You have the H here stands for hydrogen, and you can see one hydrogen, two hydrogens. So the 2 is saying that you have two H's, two hydrogens. And then there's an O, which is saying that you have one oxygen. That's that atom right there. So when people say H2O, they're saying two hydrogens and an oxygen, which is water. That's a really simple molecule, just H2O, just three atoms put together. But there are also some molecules that are very complex. For example, if you know anyone in your life who has diabetes, you've probably heard of this thing called insulin. That's a thing that people make in their bodies all the time. It helps us digest food. And this is what a molecule of insulin looks like. It is a giant molecule. You don't need, this is a little bit more advanced, so you don't need to understand this part right here. But this is the chemical formula for insulin, whereas water was just, two hydrogens and an oxygen. This means that in an insulin there are 254 carbons, 377 hydrogens, 65 nitrogens, 76 oxygens, and 6 silicons, I believe. It's a big old giant molecule. So molecules can be simple, or they can be really big and complex. And there are some that are even bigger than insulin. Alright, that finally brings us to our first classwork question today. It's our first one. Why do people sometimes call water H2O? I want you to explain this to me in your own words, using everything that we just learned about atoms, molecules, and this whole idea of calling water H2O. Pause the video, answer this classwork question now. Alright, moving forward, I have assumed you have now done that. Don't let the video keep playing if you haven't. Now, you might be wondering, because this is what I wondered when I first learned about this stuff. I was very curious, like Dwayne Johnson over here. If elements are the different types of atoms, how many elements are there, right? So like a second ago, we saw that, there's at least two, because we have hydrogen, that's one type, oxygen, that's another type. How many are there in total? Well, here's your answer, and it's an answer that has taken humanity a long, long time and a lot of scientists to figure out. There are 118 elements, at least that we know of. That means that scientists, as of 2020, have discovered 118 different elements that they are able to find in the world or create in a laboratory, and everything in the entire world is made of those 118 elements, at least everything that we know of. And if you want to actually just take a look and see, well, what are the 118 elements? Here they are. You might have seen before somewhere in life, just because you see it sometimes, a periodic table of elements. That's what you're looking at right here. And now you can actually understand what that actually means. It's a giant table, and every one of these little squares is a different element that exists in the world. It's a different type of atom. And so you can find on here some of the elements, some of the atoms that you are already really familiar with. For example, if you look right up here, this one that's called O is short for oxygen. You've heard of oxygen before. We also, when we were talking about water, talked about hydrogen. That's the smallest atom of all. It's all the way up here in this corner. And there's probably some other ones you've heard of. Like, let's see. I bet you've heard of iron. That's an example of an element. I bet you've heard of calcium. It's in milk, right? That's an example of an element. You've probably heard of sodium. That's an example of an element. There's a whole bunch of these. Maybe some of you guys have heard of sulfur or chlorine or nitrogen, right? There's a whole bunch of different elements that exist, and the periodic table, the reason why you see it in science classrooms and in laboratories all over the world, is because it is a giant table of all of the elements that exist. There's also some elements you've probably never heard of, like really crazy ones. One of my favorites is element number 23, which is called vanadium. Or in the really, so the biggest elements, the newest ones are all up here, like in numbers 113, 104, and they all get really funny names. So the biggest element of all is called ununoctium, which is just a really funny, silly name. So yeah, there's some you haven't heard of and some that you have heard of. There's a lot of elements, 118 of them. This, I want to take a moment just to appreciate how amazing the periodic table is, and what an incredible, bunch of human knowledge has had to come together for us to have a giant table of all the elements that exist in the world. There's so much information that's going on in this periodic table that you guys will be able to learn about in your high school chemistry classes and in college if you study chemistry. It really is amazing. It's in fact so amazing that there are some people who are even bigger science nerds than Mr. Manta who choose to get the periodic table tattooed on them, like this person right here. Well, they can now go around life and they are able to identify every single element that they might find because they have all of the elements tattooed right there on their skin. I'm not planning to get that tattoo, any tattoos anytime soon, but if I was, this would be a consideration. All right, I want us to jump to classroom question 2, which is for you to explain in your own words, what is the periodic table of elements? What is this big giant thing that you see in science classrooms all the time? Pause this video and answer that question in your own words now. Alright, we're moving forward. I've assumed you answered it. Don't let me move forward if you haven't. Alright, that brings us to the end of today's lesson and the independent practice as always. Number your notebooks, numbers 1 through 8. And here are those 8 questions. Pause the video, test your own knowledge, answer the 8 independent practice questions now. Alright, I'm assuming that you've done that. Let's run through some answers, see what we got. Number 1. When we say that matter is made up of particles, the two kinds of particles are really atoms and molecules. You can say molecules and atoms if you want. You can have them in either order. I don't care. Number 2, the different types of atoms that exist are called elements. Number 3, which are usually bigger, atoms or molecules? Well, molecules are going to be bigger because they're made of atoms. And so if the atoms make up molecules, then atoms must be smaller and the molecules must be bigger. Number 4, true or false? Molecules are made of atoms, but atoms aren't made of molecules. That is true. Number 5, how many different elements are there that we know of? Well, we just saw that there are 118 of them, and people organize them into the periodic table. Number 6, yes or no? Can you break down an atom into even smaller parts? No, you cannot. I'm just going to leave it there. I could give an even more complicated advanced chemistry explanation, but I don't want to confuse people any more than we have. Number 7, scientists arrange all of the elements that we know of into a giant table called the periodic table of elements. And yes, I do want you to know for quizzes and tests what the periodic table of elements is. It's a big chart of all the elements that exist. And number 8, yes or no. Molecules such as water and insulin are pretty simple and only made of a few atoms put together. That's going to be a no. We saw that molecules like insulin can be really complex and be made of hundreds of different atoms put together in a really complicated way. All right. Oh, I didn't have the little blue thing that slides up, but as always, go ahead and star those questions you got correct, fix the ones you got wrong, and then you're going to tell me in today's classwork questions which ones you got correct. And that will take us to exit ticket time, ladies and gents. Go ahead and knock out today's exit ticket. For the cool thing today, I'm really on a Lego kick from the Lego videos that we've been having from Crash Course recently. And so I went online and started watching videos of just giant Lego creations that people have made, and I think this is my favorite one that I was able to find, so I'll link it on today's work. It is a giant samurai fortress made of something like 100,000 separate Lego bricks assembled into like this giant structure the size of a whole room. It's pretty cool, but it's just optional, as always. Alright, knock out the exit ticket. You all been doing great lately, and if you did yesterday's science experiment, well, heck, send me a video of it. Alright, take care, folks. Talk to you on Monday.